Hi, this week Joranalogue posted another Tech Thursday video, and well, here I am once again with a follow-up to that video. This week Joran showed us how to use filter 8 as a slew limiter, so not just for filtering audio, but really like filtering sub-audio rate signals. And there's other filters that can do this, but well, they are very few. But filter 8 is especially interesting for this because it has a multitude of outputs, and most importantly, it has, well, CV control over everything. And that's what I will be using to my benefit in my upload. If you haven't seen this week's Tech Thursday upload, well, you really should go watch that one first. You can find it on the YouTube channel of Joranalogue Audio Design, but of course I will provide a link in the description box as well. Let's get started. In the patch like it is now, I'm doing something similar to what Joran showed us in the Tech Thursday video. I'm using step 8 to generate some kind of sequence. I'm using both the step input and the stage input, which is getting a signal from orbit 3. So, well, the order of steps is a little bit random. But I'm just generating a pitch CV sequence from the scan output. I'm running it through a quantizer here, just because I want to make this example a little bit musical. And from the quantizer, the CV signal is going through filter 8. That's not entirely true. The signal is going through data first. You can see it as the top trace, it's the green line. From there it goes into filter 8. I'm using two outputs on filter 8. The first one is the blue trace on data. And well, the third one is red trace on data. Both these signals are routed to two channel 3s. These are not tuned in octaves. It's some kind of interval that I turned on my system and it was there, and I thought it was interesting. And with filter 8 set to low mode, you can start turning down the coarse knob, and then you will hear and see on data how our stepped voltages here generated by step 8 are getting slewed. And it might be obvious that when you turn it down, it's, well, very much like a filter. You're filtering out the, well, fast moving parts, which is of course all very relative when we're talking about stepped voltages like these. But turning it down makes the slew bigger. Turning it down causes the movements to be more gentle. You can also notice that the third output here from filter 8 slews the signal in a different way. And this is of course to be expected because there's different filter topologies for the different outputs. Now with all this CV control over the frequency, I want to show you how you can introduce like a sequence with a portamento on the steps that you choose. For this I'm going to use, well, I'm not going to choose when my voltages are going to glide or be slewed. I'm going to let compare to decide for me. Compare to is receiving two gate outputs here from step 8. But because I'm not stepping through the steps in a linear fashion, the gates produced by the logic section of compare to is somewhat random. I'm just using the flip-flop output which gives me a slower moving signal. And right now this cable here is not going anywhere. But let me show you how you can use a gate signal like this to create slew. Well, we have a positive signal here, but we need to turn down this knob here for certain steps. This is just a matter of connecting the positive gate, but turning this attenuverter to the left. Which means that whenever there's a gate active here, the frequency of filter 8 will actually go down. Now, this is a bit much, at least for what I'm trying to do here. So now you can hear and see that we are getting a pitch sequence. And this sequence can come from literally everywhere. But when you have filter 8, you can introduce some kind of glide or portamento by using filter 8 as a slew limiter. The outputs of Generate 3 are going through a filter, by the way. The filter is just off screen. I'm using the Manhattan Analog MA35 for this, and it has 2 inputs, which is very convenient for dispatch. It also has a built-in VCA. And I'm sending an envelope to that VCA that is getting triggered by the step output of step 8. And this output always fires a trigger whenever step 8 is forced to change stages. So even when you're using the analog or stage input here to control the movement of the stages, this step output will fire a gate every time step 8 moves to a different stage. I think I said it exactly like that the first time. I want to add some more interest to dispatch, so I'm going to use, well, just another output of filter 8 here to modulate my decay parameter. I like how this sounds. Let's bring in some other sounds to this patch. Let's first bring in a kick drum. Then some stereo percussion, hi-hat and a snare. Let's add some effects. Yeah. And I have a sequence running on an external synth. Let's bring that in. like Joran showed us, if you introduce some resonance, a lot of resonance, you can get filter 8 to, well, self-oscillate. But because the frequency is being modulated, and, well, you might know that when you set up a self-oscillating filter, it really depends a little bit on the frequency of that filter when it starts to oscillate. So by modulating frequency, even if we're at sub-audio rates, this works. You can see that the filter oscillates at different parts of the signal. Let me grab one more cable here. I use one of these outputs to modulate my filter. This should be very apparent. Let's remove the modulation of the envelope. Then if I dare to free tune my generates here, being a little bit lower. Anyway, now you can hear that we get this, well, alternating between a filter that's being modulated by stepped voltages and kind of wobbling because of some LFO behavior. I hope you enjoyed this follow-up to Tech Thursday. I hope you learned something. See you next time. Bye.